So we already talked some about monitoring. I showed a little demo of New Relic, which is one of many APM or application performance monitoring systems out there. But the important thing, again, about monitoring, it doesn't really matter which one you use, but you should do it. If you're not monitoring something, it's probably not behaving the way you think. You should be doing some monitoring in development because you want to identify possible performance problems before they get to production. Remember that part of what's different about operations is that when your app is operating under production resource constraints and with a lot of users, it may unmask a lot of problems that would be invisible when you're just using it by yourself. So having some instrumentation in place as you're developing to warn you that, hey, you did a query here or you've got a really expensive action here, and you might not notice it in development, but in production, it could be a problem. So we'll talk about some of the kinds of conditions that are like that are worth keeping an eye out for in development. And of course, in production, you really need both kinds of instrumentation. Internal instrumentation is when there's something embedded in the app that is collecting data and lets you see that data on a dashboard, like I showed with New Relic. So there's a New Relic gem that hooks into various parts of Rails, and as your app is running, data is being collected all the time and sent off to their servers, and they have nice GUIs, and you can see pretty pictures and graphs, and you can query the heck out of everything. But you also need external monitoring. External monitoring is, the monitoring is happening from outside the app. And the most basic version of that is the app up? Is it behaving in some reasonable way? If I try to get to the app's homepage, does the homepage basically look right? Does it have all the elements on it that I expect? Is the app really slow? Maybe it's working, but the response times are bad. Or maybe the response times are bad just for people in a certain part of the world. If your app has a very wide user community, people from all different parts of the world, you actually want a sense of what is the view of my app from many different users, not just from the ones who happen to be sort of near in the internet sense of where my app is. So if your site is down, if your site is slow, you want to be able to get information that gives you a sort of composite of what it's like from different users. And like I said, we showed an example of one type of monitoring, the dashboard that New Relic provides, which I really like. Again, I have no connection, financial or otherwise, to New Relic. I am not endorsing their product except to say that I use it and I like it. What kinds of things can you monitor? There's very basic monitoring for things like availability, like is your site up? There's a service called Pingdom that will actually sort of send simple requests to your site from all different places in the world, and you can see how it's doing. New Relic will also keep external monitoring on your app, but I don't think they cover quite as wide a range of scenarios. Unhandled exceptions. This is a really important one, right? If there's an unhandled exception by default, your user will just see a page that says, sorry, something went wrong. But as the developer, you really want to know about that, because one thing you should never have in production is an unhandled exception. That's really bad. Like that's, there's actually some important case that you just didn't think of in your tests. So what you want in that case is, besides the user seeing a friendly error message, you want to capture as much detail as you can about that exception. And tools like Airbrake will actually do that for you. They'll intercept the exception, they'll do a bunch of logging, and then you can go sort of see, when did the exception happen? What was the environment at the time of the exception? It's basically like having an interactive debugger snapshot that's frozen in time. We showed how tools like New Relic and also Scout, which is another APM, will do things like keep track of which controller actions or database queries are the most expensive, so that if your app is sluggish, you can start to look for where the problems might be. You might also be interested in things that have to do with monitoring user behavior. Like how many times does the user have to click to get to the thing that they want to do? Or how many click streams of the user actually lead to whatever the conversion step is in your app. Conversion is a general term for when the app makes money. So, if you're Amazon, conversion is when the user pays for something. If you're, Netflix, conversion is when the user pays for a subscription. If you're Google, conversion is when the user clicks on a Google link that brings in some ad revenue to Google. So if you want to trace these things, there's tools like Google Analytics, which is generally free. And again, it's not so much for monitoring the performance of your app, but it's more for getting insights about user behavior. How are users behaving when they use your app? If you're the kind of person who is running your own app, which I don't recommend, then you actually also need to be looking at what we call telemetry for the individual processes. So how is my database doing? How much memory are my app servers taking up? How many connections are my web servers serving? One great reason, as we've said, to use platform as a service is that as app developers, if you don't have to worry about that, you shouldn't worry about it. You should be focused on what's the value added for your specific app, and pick a good platform provider like Heroku to actually deal with keeping the lower level processes running and sort of optimizing them. But not that long ago, before PaaS was a thing, you had to learn how to do this, right? Part of your job as a developer was you had to also be the infrastructure monitoring and make sure that your low-lying processes were working. And if they died, you'd have to have things that restarted them. So this whole, this bottom row, for the most part, most of us do not have to worry about this until you get to a scale where you have to bring all of this in-house, right? And that's the you are not Google argument. A particularly interesting example I ran across this on the web was if we use tools like Cucumber to write human-readable and customer-understandable scenarios of application behavior, could we also use that approach to write tests that are about application performance? And I found this example on the web of somebody who had used the New Relic API. So remember, New Relic is collecting all this information about your app, which means that besides seeing those nice dashboards and graphs that I showed, you could also query it using an API, and you can ask historical questions like, in the last 30 minutes, show me the distribution of response times and all of the different URIs that were hitting my app. And since you can get that information, you can imagine putting that into step definitions and writing Cucumber scenarios. So I thought this is pretty cool, right? You could say something like, given that my application is being monitored, then my response time should be less than whatever. My AppDex score should be greater than whatever. And you can have a process that sort of runs this in the background every few minutes and gives you a heads up if something fails. But what I liked about this is that, as you may have guessed, is that it's a very nice way to document what your application performance indicators actually are. Here they are, written in plain language that anybody can go read and understand. And when you actually create this as a runnable test, you now have an executable version of an English language spec. And I just love that. What about stress testing and load testing? This is the other thing that you can't really simulate well in a development environment. You have to do it either in a production environment or in a staging environment where the components are as similar as possible to production, but maybe not as big. So maybe your production database has 100 million rows, but your staging database has 1 million rows. Enough that you can sort of do interesting things without having to fully replicate every aspect of production. What kinds of things are you looking for when you do stress or load testing? One obvious one is performance. How many simultaneous users can your site really handle? At what point does it start to slow down? And that could be a function of your app, the number of web server processes that you have in front of it. Are there things like longevity bugs, memory leaks, running out of memory, running out of something in the database? I'll show you a couple of examples of that can happen that are sort of specific to software as a service. And when you do this kind of stress testing, what you'll find is that at some point, there's one thing that becomes a bottleneck. Now, that thing may be a database query that's very expensive. It may be a view that is expensive to render. It might be a controller action that's very complex. But something will become the bottleneck that limits further scalability or whatever you're trying to measure. And the way that you find it, there are load testers that are brain dead simple. You just give them a single URI and it just starts hitting your server as hard as it can to see when it dies. You can do more sophisticated things like here is a sequence of URIs, or here's a log file containing a sequence of URIs corresponding to the actions of a particular user. Replay those actions. Or kind of my favorite is if you've got Cucumber scenarios that are testing important workflows in your app, just get a setup that runs a lot of those at the same time, right? Because that's, in some sense, that's what a Cucumber scenario is. It's pretending to be a user stepping through a workflow on your app. Okay, then let's take a whole bunch of those scenarios and multiply it by like 500 users. And so there are CI sites that will do this for you. They will take your test suite and essentially throw live traffic based on your tests at your app until, your app keels over. I mentioned resource leaks as one of the longevity-related bugs that doesn't really come out in development. Memory leaks are obviously, sort of the example probably most people think of. And as I said last time, one of the ways to fix a memory leak is to reboot, restart the process, kill it and restart it. And most infrastructure providers already do this. So I mentioned that Heroku, for example, will periodically kill each of your dynos and replace it with a fresh one so that the total number of dynos running is held constant. This is called rejuvenation, and it's a pretty standard practice. Even if you're running your own web server like Apache, there's an Apache option that basically says, Apache has N workers, and here's how often to kill each one. A less obvious one, though, that in software as a service is really obvious once it bites you, is running out of database rows. And the simplest version of this is the Heroku setup that we've been using in this class. Because it's only designed for setting up sort of an app prototype, the database size that you're limited to is actually pretty small. I think it's a couple of tens of thousands of rows. which is not very much at all because that's like total rows across all of your tables. If your app is, a real app serving real users, obviously you need more space than that. And, at various times you're going to have to grow to higher database tiers. The good news is that most good PaaS providers have a way to minimally disruptively upgrade it in place. So I can go to my Heroku plan and essentially upgrade from the, 1 million rows to 10 million rows database. And Heroku will, in the background, do that migration using ideas that are not that different from the incremental feature flag migration that we saw, but it's their problem to do it. And for the most part, they can do it with little to no downtime. I just sort of pay to have the bigger database size. What are other reasons that you might run out of database? This one is a little bit less obvious, and it's kind of specific to software as a service. I don't think this one has an equivalent in shrink wrap software. I call it database pollution. So the typical scenario here is somebody goes to your e-commerce site, they put a bunch of items in their shopping cart, and then they never come back for whatever reason. Obviously, you need to be somehow storing and representing the contents of their shopping cart in the database, unless you're trying to pass all of that back and forth with a cookie, which I don't think you are because it's too much stuff. But if that user never comes back, you've got some database row that is probably never going to be used again. So in practice, whenever your app is maintaining some state that may never get officially released if the user doesn't return and finish their workflow, what you would usually do is would have a periodic sweeper process. Maybe it runs once every hour or something like that. And it looks at something like the updated at column. If you remember, when you set up an active record model, by default, Rails will add timestamp columns to your model. There's a timestamp for when a particular row was created, and there's a timestamp for the last time that it was updated or touched. So one easy thing that you can do is look at the updated at column on one of your models, and something that hasn't been updated in, a week or something, you can just delete it. So basically running, a once a few hours or however often sweeper process. The idea, again, the important concept here is this is something that it's kind of one of the trade-offs of software as a service, right? You're offering to store all the state on behalf of the user. So now when the user creates a bunch of state and doesn't use it, it's no longer their problem. It's now your problem.